Good afternoon. Thank you everyone for attending today's webinar, Proper Hose Assembly, brought to you by RICO, the Fluid Power Technology Conference, and Fluid Power World magazine. Before we get going, here are a few words about our upcoming event, which takes place in less than a month. We're happy to invite you to the Fluid Power Technology Conference that will take place at the Milwaukee School of Engineering on May 16th and 17th. The conference will bring together fluid power professionals to learn from experts during technical sessions, as well as to network with industry peers. We have some great keynote speakers, including Alan Carlson and John Thornton, who will take a look into the future of fluid power. Just for attending this webinar, we're offering 20% off your registration when you use the promo code webinar20 at checkout. For the full lineup of speakers and the detailed schedule, please visit fluidpowertechconference.com, which is located on your screen there. All right, now just a couple of housekeeping details before we get started. You should ask all of your questions related to the webinar in the Q&A box, and then after Josh, our speaker, is finished, we'll do the Q&A portion. If we do not get to your answer, our presenters may reach out to you afterwards. The webinar slides, as well as additional resources, can be found in the resource box. We do encourage you to tweet with us. Simply sign in through the Twitter box. Today's hashtag will automatically be added to your tweets. And if you have any questions specifically about the ON24 system or need help, please refer to the help widget on the bottom of your screen. If you're watching this on demand, you can still use all of the features that I just went over. And then lastly, there is a bio widget with all the presenter information, including emails. Now, my name is Paul Heaney, and I'm the editorial director for Fluid Power World. A little bit of background on me. I have a mechanical engineering degree from Georgia Tech, and I have been covering the engineering and manufacturing worlds for more than 20 years. I'm pleased to be your moderator here today. I'd like to take this opportunity to thank our presenter for being here and to introduce him. Josh Cosford is a contributing editor for Fluid Power World. He's one of our favorite writers. He studied fluid power at Mohawk College in Hamilton, Ontario, where he currently resides. Josh has more than a decade of experience with fluid power systems, and he has held the Certified Fluid Power Hydraulic Specialist designation from the Fluid Power Society since 2009. Josh has been involved in the design and sales of hydraulic systems since 2006. And now, without further ado, I'm going to hand the mic over to Josh. Josh?
Thank you very much, Paul, and welcome everybody that's attending today. Thank you for joining us. This webinar is on proper hose assembly. It's going to cover all the basics on how you need to make a new or used hose and do it safely and effectively. So obviously hydraulic hoses exist on nearly every machine that is hydraulic. It's critical to ensure hose assemblies are fabricated with care to ensure reliability of the hose and the hydraulic system they're part of. This presentation covers the essentials of hydraulic hose assembly to ensure the machine is safe and dependable. So what we're going to cover today, we're going to cover how to measure a hose assembly accurately, to skive or not to skive, that is the question, what hose to choose for the application, and why hose flexibility matters. So you have to consider an important first step. Identify what you need. Sounds simple, you want a hose, but there's more to it than that. So is it a new hose assembly, or is it a replacement hose assembly? As you can see, this one's pretty old, needs to be replaced. So new hydraulic hose assembly should be chosen with consideration to their specific application. So if you're creating a new hose from scratch, you need to lay it all out to decide what kind of hose you need. And you may have seen this trusty acronym stamped. So every letter stands for something. We have size, temperature, application, material, the pressure, the ends, and then delivery. Delivery being how much you need and when. I'm going to go through this acronym, the stamped, and discuss every stage of hose selection up towards assembly. So first consideration is size. So the size includes the ID, the OD, and the length. So ID of the hose is critical. because the hose must be sized appropriately to handle the flow with a little pressure drop. So if you have a system with 12 gallons a minute of flow, something around the half-inch hose is probably pretty good. If you're at 30, 40 gallons a minute, half-inch is no longer acceptable. There's too much pressure drop. I've seen applications of 500 feet of hose on a underwater robot that was run by hydraulics, and it had 1.5 gallons a minute of flow, and even using quarter-inch hose caused 1,500 psi of pressure drop. So that just shows you how critical hose diameter can be. So measuring the length. So a lot of people will take an old hose assembly they pull off a machine, or just kind of a new assembly that they've had somewhere and they're trying to copy it, and they'll measure the entire tip-to-tip length. That's not really the right way to do it. If you try to copy that, you'll end up having hose lengths that may not fit to the machine that they came off of. So using this example, the overall hose assembly length is actually where the fittings join. So on the left side, you have this JSE female. It mates up to where the male side of the JSE is inside the fitting itself, not at the tip of the threads. On the right side, on that 45-degree elbow, you can see that the hose link is onto the center point of that fitting, not to the very tip. So it's critical to measure a hose so that it's at its mating point rather than at its entire tip-to-tip length. So one thing to factor when you're going to size up your hose, it's good to get the whole end-to-end length of the measuring of the hose, and just the example that we had. But that's not what you want to cut your hose to. If you cut your hose to that entire measured length, then your hose is going to be too long. I'd rather have a hose that is too long than too short, but it can cause bunching and vibration, and it just might not fit and look pleasant in the end. So one thing you have to factor is how far the hose goes into the fittings. So what we have here on a hose is what we call the cutoff factor. So each end of the fittings has a factor for how far the hose is pushed into the fitting itself. So you have to subtract that from the total hose length. So moving on to temperature. This is critical for applications and which type of hose you choose. So what is the temperature of the fluid, which is important, and then also what is the ambient temperature, which is often more important. So a typical hydraulic hose is good for minus 40 Fahrenheit up to 212 Fahrenheit. Now, why this is an important consideration for ambient temperatures, because no hydraulic oil likes to be up to 212. At that point, you're cooking it, you're boiling any dissolved water that's saturated within the fluid. You're oxidizing it very quickly. The fluid would varnish very quickly. So it's just a terrible condition to have hydraulic fluid that is that hot. However, you need to be able to handle ambient temperatures. So in machinery, mobile machinery specifically, where you could have hoses running right past an engine or near exhaust components underneath the chassis of a truck. So examples in a steel mill as well. So you might have high temperature hose that is good for 300 plus Fahrenheit. I should specify that's also at ambient temperatures. Even if you have high water-based fluids that are fire resistant, you still have to have hose that is going to resist melting or fracturing or softening and having the whole hose ends come apart. But I should mention that when it comes to handling those kind of temperatures, a high temperature hose up to 300 is for ambient temperatures, not for the fluid itself. And conversely, you can have a low temperature hose. So this can be good to minus 58 Fahrenheit or lower. And so this is for cold ambient conditions. So here we have an excavator running in some Arctic temperatures. The machines are so reliable these days; they can run all year round. I mean, you used to have construction season from May to September, and now construction season lasts all year long. And that's because of the nature of hydraulic machinery and how much more reliable they are. What happens is when you have a cold hose, it becomes more brittle, so it'll crack and fracture, but it could also just have a poor bend radius or just poor reliability. So cold temperature hose could be appropriate. So then discussing further, we have your application. So this is specific to what this is, regardless of all the other factors. So where is the hose being used, and then what is the required bend radius? So these are application details. So when discussing a bend radius, here we have this picture. I'm actually showing bend diameter, but bend radius would be half that dimension. So this is an example where you have two components that need to be closely mounted to each other. The ideal situation is these would be hard plumbed with tubing, but there are some cases where you have to use hose for vibration resistance, or perhaps the two components they move away from each other, so they could be on a boom, or they could be on a cable track or something like that, so that like on an injection molding machine platen. So high bend radius hose can be used, which is often twice the flexibility of standard hydraulic hoses. Okay, so more details about the application. What are the external conditions? Not just about cold weather, but is there risk of abrasion or corrosion or electrical conductivity? So abrasion-resistant hoses exist. So the outer cover is reinforced so that it can rub against things without wearing away. So it has a tougher cover. You might have corrosion-resistant braiding. So, for example, a lot of hose will have braided or spiral steel. You may have a synthetic fiber, such as Kevlar, as that braid, which obviously will not rust, because any water that gets onto a hose, the cover is permeable. Water can seep through, and if you go back to that image I saw earlier with the used hose, that braiding can rust, and as it rusts, it loses strength. And you can have hose breaks and bursts. So having corrosion-resistant braiding material could be important. If you work around power lines, like you see in this picture here, you want to have electrical conductivity avoided at all costs. So you can imagine the hydraulic hose will touch one of these power lines and then conduct electricity right through the machine into the ground or to the operators. So they use a non-conductive hose that would be of a synthetic material that can still handle pressure without actually conducting electricity. So the next step is selecting your material. So what type of fluid is being used, and this is critical to hose selection. So the standard mineral-based hydraulic fluid is compatible with most hose types. So most hose types might have a nitrile buna tube on the inside, so that'd be the inner portion of the hose. And most standard hydraulic oil, the AW68 or what have you, the industrial oils, and most of the machine oils that we use, transmission oils, ATF, that stuff's usually good with most of your standard hydraulic hose constructions. But you could have some exotic fluids like phosphate ester, which require synthetic hoses made of EPDM. So it's a little bit of a more nasty or corrosive fluid that requires a more, I wouldn't say stronger, but something that is better for compatibility, something that will not break down or crack or become brittle because of the nature of the fluid. And there are cases, too, where you have high water-based fluids that may affect your selection of hydraulic hose as well. High water-based fluids might have an emulsion or some other glycol or something like that, but still the content of water then can make them react with the steel braiding and have it rust over time as well. And then pressure. Of course, pressure is what hydraulics is all about. So pressure capacity is the defining criteria for a hydraulic hose. So it's why it exists, and it's why hydraulics is the magical principle that it is. And the pressure capacity that you need dictates hose construction. So there are a lot of ways to skin a cat, and there's also a lot of ways to make hydraulic hose. So the pressure that you need, combined with all the other factors I've spoken about so far, will affect the construction of that hose. So hose construction dictates the pressure capacity of the hose. So just as I said, depending how it's constructed will depend on how you can rate your hose for pressure. So the three layers of a standard hydraulic hose, this is what we call a one-wire hose. You have the cover, the reinforcement, and the tube. The cover is on the outside. The reinforcement, in this case, it is braided wire. Now, when we say one-wire hose, there's not literally one wire that has been wound around a million times. It just means one layer of wire. So in this case, you have one wire. It's one layer of braided hose. So by braided, it means this crisscross fashion of strings of steel braiding. And this is pretty tough, but it's also pretty flexible. So the one-wire hose is typically the lighter duty of the selections, but also very flexible. And then the type of cover and reinforcement and tube are also factors in like your abrasion resistance, your conductivity, and then the tube can affect the chemical compatibility of your hose. So here we have a 2-wire hydraulic hose. You can see there are 2 layers of braided wire, each separated by its own slice of rubber between each sets of braids. This type of hose is obviously a lot stronger. It can handle a lot more pressure, and still being braided has a fair amount of flexibility to it. Stepping up a notch, here we have a 4-wire design, and you can see that the braiding is not braiding at all, but spiral. So this spiral round, every direction of wire is crisscrossed so that the spirals go in an opposite helical direction. This adds even more strength. Just having the number of wire layers adds strength, but the downside of this type of hosing is you start to have reduced flexibility. So as these hoses become bigger, as the pressure capacity increases, so does the stiffness. There's an inverse proportionality between the size of the hose and the pressure capacity. Good quality hose can generally handle pressure from any size, from 1/4 inch up to 2 inch or larger. But some of the standard braided hoses, the smaller it is, the higher the pressure it has. So, for example, a 1-wire 1/4 inch hose could probably handle 5,000 psi. And that's just because of the nature of pressure and the amount of force vectors that it has to push on the idea of that hose. So just without getting any physics or math, the smaller it is, the more inherently it is strong so that it can handle pressure all by itself. The larger you go, the more surface area there is for pressure to push upon, and more opportunity for the forces to want to make it burst outward. It's the same reason that a large hydraulic cylinder makes more force than a small hydraulic cylinder. So kicking it up a notch once again, here we have 6-wire spiral hose. So you can imagine that the pressure capacity increased even further. This one actually has a couple layers of cover on it. So it could be for chemical compatibility, heat. It could be for abrasion resistance. But this is some pretty heavy-duty hose right here. So if you flip through the catalogs of any given hose supplier, in this case we're looking at some Ryco H6000, their Die-Hard series hose. It's going to give you all of the parameters and specifications of that particular hose. So it's going to start with your hose number, the dash size. Here's a little trick. If you guys have heard the dash size before, just look at this chart. You can see the dash size in 06, which equals 3/8, and 08 equals 1/2. The 12 equals 3/4. There's a pattern there, and somebody thought it'd be clever to make a dash size, that number, over 16. So, for example, dash 6 is 6/16, which is also 3/8. So really the dash size really just expresses the fractional inch size, if you didn't already know that. So the dash size, which is also the nominal ID of the hose, and it's nominal because it's not always exactly that diameter, and then the nominal OD of the hose. In this case, you also get your maximum working pressure. This is the pressure that a hose can work day in and day out. So this particular Die-Hard hose will work at 6,100 psi all day long till the cows come home, and every size that they offer in this will operate at that pressure. That's just because of the nature of its construction. The burst pressure is what they offer as the maximum pressure before this hose will generally explode or have a rupture in it. So the entire thing is not going to be catastrophic like an exploding propane tank, but the nature of hydraulics and the bulk modulus of oil will mean that you'll have a tiny pinhole and a squirt, and something will give way and allow pressure to bleed out or drop quickly. You can see in this case, the minimum burst pressure is exactly 4 times the maximum working pressure. In most cases, hydraulic hose is rated on a 4-to-1 safety factor. That's the same thing for hydraulic cylinders, like an NFPA cylinder. Typically, you're rated for maximum burst or fatigue strength is 4 times what your working pressure is, and they call that the safety factor. Included in the chart, you can see that they talk about the minimum bend radius. So this is important. We were talking about the applications and specific to how tight you can have components mounted together and still have a hose fit between them. And as well, if you have a hose that continually sweeps through an arc, something that is on like a boom or whatnot, how far that you can move those two moving connections before you can over fatigue the hose. There's lots of times where you can go smaller radius on a bend, but you can force it in a press to be literally folded in half, but at some point they will fatigue it and it will break. So this is the minimum bend radius, so the smallest you should generally go. Then also the average weight. This is also important. So if you look at the pounds per foot, so for every foot of this hose, it's going to give you the pound of this hose. For example, the Dash 12 hose, 0.93 is just shy of a pound for 1 foot of hose. That's important consideration if you're in mobile applications where anytime you add in a pound of machinery, you're taking away a pound of payload. So just as a quick comparison, this is the Ryko T1A, which I think has been discontinued, but regardless, you can see the different sizes. You can see that they are different. So if you look at the OD of the hoses, and we'll compare one in a second. Generally, because it's a low pressure hose, it's a smaller OD. It's going to have reduced working pressure. So right across the board, you can see my point earlier where this 3/16 hose has 3,600 psi rating. And as you go larger in diameter, nothing changes about the construction, but just because of the nature of larger diameter and the forces that are applied to it, you have a reduced maximum working pressure. And once again, you have your minimum burst pressure, which is 4 times the working pressure. There's an advantage to this, of course, when you have a lower pressure rated hose. So this is why when it comes to choosing hoses, sometimes it's good to know exactly what pressure you want to run at. If you have a system that is running 1,500 psi, do you really need to choose a 3,600 psi or 6,000 psi hose? Not really. You can save cost, you can save weight, you can have improved bend radius by going to something lighter duty. So these ones will have a tighter bend radius, and they will also weigh quite a bit less per foot. So here I took the two and compared them in the Dash 16, which if you take 16 over 16, you get exactly 1 inch. Goes back to that whole dash sizing thing. And then we're going to compare every single factor along the way here. So if you want to compare heavy duty and light duty. So on this size, you can see that the nominal hose OD is larger on the H6000D series. So that's because it has the anywhere from 4, 6, or 8, depending on the size of the hose. Like so, the diameter, larger diameter hoses in that hose series will have 4, 6, or 8. So probably 6 or 8, depending on. Anyway, the larger it goes, the more spiral-bound wires there will be. And you need to have a thicker hose in that case. So in this case, it's not very much. It's 80 thou, but still counts for a larger fitting or crimp that you have to put on it eventually. But look at the dramatic difference in maximum working pressure. So at just 1,300 psi working pressure for the 1-inch T1A compared to the H6000. And then, of course, burst pressure being 4 times that. But here's where you have a trade-off. Looking at the bend radius, you can see that you can go on the T1A an inch tighter in the radius, which means 2 inches better on a whole circumference, or diameter, I mean. And then once again, in weight, this is where it really gets dramatic. So if you have a mobile piece of machinery that is not an excavator running 4,000 psi plus, you can see where the weight savings come in. And this is per foot. And, I've seen some trailers and other pieces of equipment that literally have hoses running the length of a 50-foot trailer. And if you add up all that weight of hose, you can imagine twice the weight of a 4-wire hose, or this one could be 6-wire in this case. So that really adds up. So back to our stamped acronym. So now we're going to talk about the ends of a hose. So there's lots of ways you can do this. You can talk about the type of ends you want, which can be male or female. You can have swivels. You can have straights or elbows. And then any of those combinations can be permanent, which means crimped on, or they can be reusable, which is also what's called field fittings. So the choices are endless. Every fitting that you have on a machine that needs to be plugged into, they make a hose fitting for it. We have some banjo fittings here. We have some metric, some JSE, some end face seal. We have some NPT fuel fittings there that are swivel on. You name it, we got it. So reusable fittings, which are also called field attachable, that's your first choice. I've spent a lot of time working with these in my day. Back in my car wash days, that was really all we used. We didn't have a crimp machine there. We had a vise and a wrench, and we could do these things in the field. Crimped-on fittings are permanent, so also done a lot of this in my day. So this requires specific machinery, which we'll talk about shortly. So you may have seen these reusable hose ends. One end will go on the hose itself. The other end gets inserted into the hose. I'll explain a little more on this in a bit. And of course, your crimped hose ends. So these will slide onto the hose, and your crimping machine will crimp it down permanently onto the hose. Once again, available in various sizes. So the special machinery required if you are doing a permanent crimp hose, what we have here is a hand pump style crimping machine. What you have here is a set of dies, and there's a tray there below that you open up, and it's got all your dies that are all in there. You change the dies in the machine based on the diameter of the hose that you're going to be crimping. Each set of dies will do a range of hose. So you might have one set of dies that can do between 3/8 and 1/2 inch hose. And then you'd insert a larger set of dies to do your 5/8 3/4. So there's a dial on the front of this as well. So based on the specifications given to you by the hose manufacturer and the fitting manufacturer, it'll set a particular diameter. That dial is a micrometer that allows you to set that distance so that it'll automatically stop crimping at the desired diameter. As far as a crimper goes, this is pretty inexpensive, and it's pretty portable as well. You see these things on the back of a service truck. But any average hose shop will have something more like this. This is a little bit fancy. It's got a hydraulic valve on here, and it's all hydraulically powered. Plugs into the wall, and it's electrical. This guy is accurate. It's got the full complement of dies in it, and you can see there's even a chart on the front of it to help you with your micrometer and all your settings to make it quick and easy. If you're a very high volume shop, you have something like this, a CNC crimper. So as you can see, this is absolutely ginormous and in the size of hose that you can crimp. I wouldn't want to be this guy because that hose probably weighs 100 pounds. So like I said, once you have your crimper, and this is more in line with most of you either have used or will be using or will see anywhere in our shop, you'll take this machine and then look into the data given to you by your hose and fitting manufacturer. So here is you might see this in the front of a catalog. This is some more Ryco components, and it'll show you the types of hoses that are color-coded with the type of fittings that you can use for that particular hose. Flip into the general catalogs, you will see they give you that cutoff factor, so that's that CA. So every fitting is going to have a different cutoff factor, so when you're measuring your hose end to end, you'll then subtract a cutoff factor, and those two cutoff factors are subtracted from your whole hose length is the length that you cut your hose at. And you can see that it's listed here, for example, right? So I think that's in metric, so 25 would be about an inch. And once again, you can see those dash sizes used. 02 is 1/8, 04 is 1/4, 06 is 3/8, etc. So cross-referencing further, so you can see the Die Hard, the Avenger, and the Slider, the different series of hoses that they're using, and then now of their isobaric braid hose. Now they're showing you the different types of couplings that you can use for it, the T1000 or T2000 series. These are set for really rapid production. What they have is a set of dies, and they're color-coded so that the assembly technician can easily grab the set of dies, plop them in the machine, and then your rapid number is the setting you set the machine to that will give you the good crimp right away. So the idea is you set that up, you set your dies, you set that number, cut your hose, put the fitting on, crimp it. After you crimp it, that crimp diameter, so you see the crimp with a 0 with a circle through it, that's your finished crimp diameter. So for example, if you're going to be doing the T3010A, The third from the bottom hose, you want that final crimp diameter to be 1.035 inches. And that's a pretty accurate number, and that's pretty specific. And how do you get that? You get it with a set of calipers. So you can get these at any kind of tool store or any one of your machine suppliers. So that'll give you down to thousandths of an inch. In this case, this one gives half a thou. So you use this to measure your hose to make sure it is. There's a range you could get within a few thou either side. Some ranges could be bigger. It doesn't have to be bang on every time, but it'll let you know either your machine is out of calibration or you insert the wrong dies or even you set it to the wrong setting. This makes sure that every hose is crimped right the first time and that the fittings are not going to pop off on you. Finally, you want to talk about delivery. How many hose assemblies do you need? How soon do you need them? Any special tagging or ley line information? So if you're an OEM, you have the advantage of any of the large hose suppliers will be able to provide for you hose assemblies with a custom ley line. Will come with series numbers or entire hose kits. So if you have a particular, let's say a stone slinger machine, and your entire hose kits that could be coming from your hose supplier, every hose needed to plumb up that entire machine will be coded, will be tagged, and will be included in this kit so that when you're assembling that machine, it's all there for you. It all goes on the machine first time. Everything's accurate and repeatable. And if you are working with some of the very large hose manufacturers and you're a small guy and you want to have custom ley line information that says Bob's Hydraulic Shop, you can have that made as well as long as you're buying a certain amount or you're willing to pay for it. So on to, if that was all the information for a new hose, but if you're going to work on an old hose, so here you can see a burst hose. What do you do if you're replacing an old hose? So do not try to repair the old hose unless absolutely necessary. And so the best thing for you to do is follow the stamp protocol to ensure that the hose replacement is correct. However, there are times where it is okay to use it, but if you have to use up an old hose, and for any matter, this type of saw is used for new or old hose. What's important is you have to use a saw that is specific to cutting hose. They have an all-metal blade. Using an abrasive cutoff wheel can work if you're short, but it tends to not look so good as an end result. So unless you use a specific hose with a metal blade, one second here, the slide's not coming up. There we go. You can have frayed hoses. Obviously, that's not a hose, but I have seen hoses used with an abrasive wheel look like that in the end if you're using a non-specialized metal blade on that saw. So also ensure that you cut exactly 90 degrees. So if not, if you cut on an angle 45 or anything, that the hose will not be inserted into the fitting all the way, and you'll not get a proper crimp, and that hose crimp could pop off. So skiving, we talked about this earlier, and we're going to mention it. So skiving is the process of removing the outer cover and sometimes the inner cover. So the thing about skiving is you need special equipment. So the whole idea with skiving is it allows you to use those reusable fittings. I'll get those in a second. What's important is you have these, foot-operated ones, and you have these handheld ones that can go on a workbench on a vise. And what you do is you spin them around, or the machine spins around and removes a bunch of material, makes a bit of a mess. But the idea is that when you use a reusable hose fitting, right? So what you have here is the two-piece hose fittings that you can install in the field. If you have a broken hose on the machine, you can splice in an attachment, or just kind of get yourself by until you can get to a hose shop and get a proper hose made. But like I said, in the car wash business that I worked at, we use these all the time. So when I was a young kid and out in a car wash bay, we had a hose break, and we would just typically the hoses tend to break right at the fitting because that's where there's the most tension, the most bending, the most fraying. And you would just cut it off. You would put one of these on and reattach your pressure washer gun or what have you. What you do once you cut your hose, you have your hose side here, you have your fitting side, attach them together, and Bob's your uncle. So the hose side goes around in a left-handed thread, you should remember that, onto your hose. The idea is that if it's skived, you don't have to push this threading through the cover of the hose. So not only is there more friction, but it bites into the rubber. The idea is that you want those teeth to bite into the braiding itself. That's going to be the strongest connection. And once you have that threaded on after it's skived, you put in the fitting side, and that will push the hose outward to the teeth that are on the hose side fitting. That allows you to have a secure bite into the hose. In the car wash, I never use the skiving. We always just use it straight onto the hose. Otherwise, if you have to use specialized skiving equipment, what's the point of having a field assembled hose assembly? So that's kind of my opinion on it. But if you are out there and you are working with skiving, continue to do so. It is the safest and most reliable. One thing I can mention that once, if you do try to use these reusable fittings on hydraulic hose, as the hose warms up, what happens is the rubber becomes softer and more likely to release that soft material because the hose side will not bite all the way into the braiding if you have the cover still attached to the hose. So it'll just pull the entire thing off the braiding because it never actually bit down into it. So and that gets worse as hose heats up. Any hydraulic application, obviously hydraulic oil heats up, and you'll have an unreliable hose. Anyway, so regardless of using reusable, or actually you can't crimp a reusable fitting, but getting back to your completed hose assemblies, once you have it crimped, so you will use the specifications spelled out by the hose and fitting manufacturer. You set up your machine and then crimp your hose. Once again, making sure that you measure it and that it conforms to what the manufacturer spells out in their catalog, that exact crimp diameter. And then you have a completed hose assembly. These are example hoses. I haven't seen too many hoses that are useful at this length. So after you have a hose assembly, you need to clean the hoses. Okay, so if you are a large company with a lot of hydraulic machinery and a lot of highly trained hydraulic individuals, you know how important it is to have clean hydraulic oil. One of the sources of hydraulic contamination is from ingression. So ingression happens anywhere where it's added to the system, through just plain dirt dropping into a reservoir, from steel filings, or from anywhere outside the system. And you don't want to be additive to that if you're doing hydraulic hose assembly. You need to clean the hose so that the particles from cutting this and skiving and crimping, the entire process doesn't add to the contamination of the system, especially if you're trying to adhere to a particular ISO code of cleanliness. So you need to use only approved cleaning apparatus, and there are a couple companies out there that do it. I'm sure you've all seen it in advertisements. After you clean the hose, you must immediately cap the hose to protect from environmental contamination. So they may go in a shipping area, or they maybe go to an area on a machine integrator where they build the machine, where there's grinding and welding. You want these hoses laying around with the ends open, or everything just falls right into it. So then you'll cap it. So there we are. Here's a cleaning apparatus. There are some foam pellets that you will insert into the blue portion of this. And it kind of opens and closes. You insert the pellet. Fires the pellet through the hose, picking up all of the contamination. The idea is to fire this in both directions. Typically, you fire this after the hose assembly is manufactured. Shoot it out the other end, and then cap it. Having worked in hose assembly shops myself, it was a great blast shooting the foam pellets at your colleagues. It's pretty harmless, but just don't let your boss catch you doing it. Immediately cap the hose, like I said. This protects it from any ingress contamination. And then you have yourself a complete hose. And that is the end of my presentation.
All right, thank you, Josh. We are now going to use the remaining time for questions. We do have some of them that have been coming in, but it is not too late to send in your question if you have one. You can simply use the dialog box located there on your screen. All right, Josh, first one is, so why do we need to skive a hose if it's not necessary?
So I kind of touched on that a bit. Like I said, I mean, I'm being a little facetious. You know, a car wash application is obviously not so critical as an excavator or other piece of machinery that safety is paramount, reliability is paramount. You know, when I worked in the car wash, cold water that ran through the hoses, it kept the hose cover and the inner tube, you know, fairly hard and rigid, and the fitting stayed on a little longer. But when the winter rolled around, because this was in Ontario, we turned on the hot water, and next thing you know, you're popping fittings left and right. Mm-hmm. They just literally blow right off the end, and you know, you'd have customers complaining that they got all wet because the hose was flopping everywhere. So it's really reliability. So you know, the right thing to do is to skive it if you're using reusable fittings. It allows the fitting to bite into the braiding rather than just rest atop the cover. If that cover peels back or pulls off, you know, you're just going to have failures. And for hydraulic applications where reliability and safety is paramount, that's the main reason you really should skive.
All right. What happens if you don't measure your crimped fitting?
If you don't measure your crimped fitting, so after you crimp a hose and don't measure it, so I suppose you could get lucky. I mean, if you set up your machine and you know, going back to that one slide that showed the different crimp diameters. So in this case, if you look at that T3010A, that first series that you want to crimp to 1.035, if you set up your machine properly and it's calibrated, it probably will be very close to that every single time. You can see in this case the tolerance is plus or minus 8 thousandths of an inch. So you could crimp it to 1.027 to 1.043. Anywhere in that range, the hose is still valid. But you don't know where you're at, so you either risk over crimping and restricting flow or damaging the braiding on the hose, or you risk it not being crimped enough and blowing off a hose end. So, you know, for the cost of one of these calipers, there's really no harm in going out and buying one for $10, $15, $20 to make sure that you're not responsible for a hose failure.
Mm-hmm. Josh, is it better to have a hose that's measured too short or too long?
That's a good question. So I would say I would rather have a hose that is too long. A hose that is too short, it tends to put pressure on the connection between the hose and the fittings. That is usually the number one spot of failure in a hydraulic hose. So there are chances of a hose somewhere in the middle getting pinched or damaged physically. But wear over time happens because between two places it can't move. So, you know, the hose can move, but the fitting cannot, and that causes tension or compression and wear right at the connection between the hose and the fitting. So when you try to make hoses that are too tight, you create that tension and just you have premature hose failure. If a hose is too long, you kind of risk it laying where it shouldn't, rubbing on things that it shouldn't, and that can cause a quick failure too if there's a lot of vibration. But it at least allows for enough slack in the hose. And you could always use hose clamps and clamp down a hose that's too long. But I would have to say that I would go for a hose that is longer than shorter.
Okay. We've had a couple very general questions about the lifespan of hoses. I realize that's kind of hard to pin down, but maybe, Josh, could you speak a little bit about, you know, how maybe the lifespan of hoses could be compromised when you're you know, not following the proper procedures?
That's exactly it. So everything that we've talked about today allows for the most reliable hose, and that's going to last the longest. So first of all, making the correct selection that is compatible to your fluid, to your ambient conditions. If you need a hose that is abrasion resistant, that you choose that, and that once you choose the correct hose for your application, that you also install it and manufacture it correctly. So making sure those crimp diameters are accurate so that it's not too loose or too tight. Making sure that you cover it with a sleeve if you're in a high abrasion environment. So hose wrap is either plastic, synthetic wrap that goes around a hose that stops it from rubbing against the surface or joints or other things like that. So everything we talked about today, if you adhere to these things, if you choose the right hose, you choose the right ends, and you install it and crimp it properly, you're going to have the most longevity. And it's just like anything in a hydraulic system, it's about choosing the right component for an application.
Perfect. Thank you, Josh. Well, that's all the time that we have questions for today. If you think of some additional questions, you're welcome to email those to me at pheeney@wtwhmedia.com. Thank you, everyone, for attending this webinar from Fluid Power World and from our sponsors, RightGo and the Fluid Power Technology Conference. This presentation will be emailed to everyone in the coming days, and then it will also be available at fluidpowerworld.com. Thanks once again to Josh for all of his insights, and have a great rest of your day, everyone. Goodbye.